Remember this? Yes, I returned to working on the Philco Safari chassis. And it's been quite a few weeks. So what I'm going to do now is to, before I really start to dig in, so to speak, is to replace the big electrolytic I unmounted a few weeks ago. As you remember, the electrolytic is one which is placed here on these pins of the power supply, yeah, and they are built in here. So what I'm going to do actually is to take the time to restuff the electrolytic, this one, with the proper capacitor. I mean, I've had the proper capacitor, which is 2000 microfarads, as you can see, and apparently 10 volts. So I've had the capacitor for a while already, so I'm going to restuff this one. And what I'm going to do next is to check the lists I had been drawing up of all the capacitors that are needed to repair this PCB. Now, you might recall that in one of the, I think the first episode, we disconnected this PCB from the tuner. As you can see here, there's this little, well, BNC-like connector. It's not BNC, it's rather a kind of a kinch connector, and it was connected down here to the tuner. This little block here, this is the tuner. Now I do recall that I said that I wanted to do the refurbishing of the Safari PCB by PCB, meaning by that I unmounted the IF PCB, which you see here, first, and I'll do the capacitors on this PCB first, and then I'll remount it and I'll unmount the other PCB, which contains among other things the video driving mechanism. And when the capacitors on that PCB are all changed, then I'm going to open up the high voltage cage, which you see here, this cage, and have a look at the high voltage section of the TV. Lastly, I'll do this part, and if I'm not mistaken, but I could be wrong, this is the vertical drive PCB. It could be the horizontal drive, but I think it's the vertical drive. I need to have a peek at the schematic. In any case, I will have to re-familiarize myself with the layout of the whole Safari chassis. Now, as you can tell by the looks of it, you see there are quite a few capacitors on this PCB. And you'll also notice there are no tubes, but there are plenty of transistors. I mean, like this one here, or this one over there. This is also a transistor. There's one hidden down here, yeah, and one here. So there are plenty of transistors. There are even a few transistors over there, and I even suspect they are gold-plated transistors here. Now, the thing is, this is a transistor-driven chassis. Aside from the two rectifier tubes and obviously the picture tube, which are used in the chassis, all the rest is transistor-driven. Now, the point is, with tube-driven appliances, you can pull out the tubes and put them to the side, and you know, if you're careful enough, they're safe. With transistors, it's a whole different ball game, yeah? And you see, each transistor can be different. You have very thin, high transistors like this one, or very flat, dense transistors like this one, or even big, clunky transistors like that one, or even this one, which is a power transistor, yeah? So, the point is, transistors are very, very sensitive to static electricity. If you're going to work on transistors, you better make sure that you don't have any static electricity on you, which means that you regularly discharge yourself by touching the ground. And I mean by that the physical ground of the power outlet, yeah, the ground. Or if you can, you connect yourself with a little wire around your wrist or around your ankle to, for example, a copper pipe running into the ground. That should give you enough grounding to work on a circuit like this. Now, in general, you know, I don't permanently connect myself to ground. What I do is, from time to time, I just touch either a grounding wire or a metal pipe, a water pipe or a heating pipe, to discharge myself of static electricity. And in general, that is sufficient. Now, the other problem, as you can imagine, is that all the parts on this PCB are soldered to copper traces. Now, let me show you what I mean. If you swivel the chassis like this, you can see underneath all the parts on top are soldered to the PCB, and rather to copper traces on top of the PCB. Now, some of you might remember my restoration of the Motorola 5T13P portable radio, and it had a similar PCB. Now, some of the traces I had to heat up quite a bit to make the part release. Obviously, the Safari is a little bit more precious to me than the Motorola. So I'll have to take double care not to overheat the tracer. So what I'm probably going to do is I'm going to mark out each and every trace or each and every solder point which connects to a capacitor, and then use the solder pump to remove any excess solder first. So for those amongst you who do not know what a solder pump is, at least if I can, here it is. A solder pump is something like this, yeah. So you can push the pump down or load the pump, as it were, like this. Then you put the Ah, yes, and there is some solder. Okay, then you push the nozzle, which is made of heat-resistant, heat-resistant polymer, the same type of polymer they use in certain baking pans, right up to the solder point, which you heated up. And when the solder melts, you simply push on the button there to release the pump. And it will, with a bit of luck, it will suck up all the melted solder at its tip, at its nozzle. So that's what I'm going to do. I'm going to mark every spot to which a capacitor is attached, and then I'm going to heat up every spot until it melts and suck the solder up with my solder pump. And I can tell you right now I'll be busy for quite a while, because on this specific PCB, if you take a careful look, hang on, I need to juggle this because it's quite heavy. As you can see on the PCB, there are quite a few capacitors. I can see a bunch of them right here, and then there are a few here, and then there are a few more here, and you see there are also quite a few ceramic capacitors, as you can see here. So well, frankly, this is hell. I mean, if I look carefully at the whole PCB, oh, I'd guess there are 30 capacitors or something like that. So that will take me quite a bit of time. Also, I'm not quite sure I have all the necessary capacitors. So it's quite probable I'll have to order a few capacitors. Also, there's one specific problem with this PCB. As you can see here, this piece of metal here, this whole piece here, is attached to the PCB, and this attaches the whole PCB to the frame of the chassis, namely to these attachment points here. This one, and that one, and then there is one down there at the bottom. And then there's another one here, and there's one here. So there are quite a few attachment points. And this is part of the attachment to attach this PCB to the chassis. Yeah. In effect, it's what they call a self-carrying body. Yeah, pretty much like cars are built nowadays. You know, they make different body parts, and they screw them or glue them together. And that not only makes the box of the car, let's say, or the metal work of the car, it also makes for the chassis of the car, the structural load-bearing part of the car. And they pretty much did the same thing here. Now, the problem is that you can see the PCB has been soldered to this part. Yeah, and this is one of the solder points here, and there's another one here. Yeah, and I imagine that there is probably another one down here somewhere. Although, because of all these wires, I don't know where it is. I can't localize it right now. Anyway, I'm pretty certain that down here somewhere there's another solder point. Now, okay, I can hear you think, well, okay, so what? Well, what's the problem with that? Well, if you take a look at this part of the PCB, you can see there are 1, 2, 3 capacitors here on this part of the PCB, yeah, on this side of the PCB. Now, as you can see here, the metal part runs down the PCB, the back of the PCB, for quite a distance, yeah. I'd say, about an inch, a goodly inch, which means that if I need to unsolder these capacitors, I will probably need to unsolder this part too. Oh dear, yes. So that's what I'm going to do next. So I'm going to restuff the electrolytic, which you see over there, and I'm going to unsolder this part from the PCB. And when that is done, once I unsoldered this part of the PCB away from the PCB, then I'll check once more the inventory I made a few weeks ago, the inventory list of all the capacitors on the PCB. And when that is done, then I'll start the very tedious task of unsoldering all the capacitors and changing them for new ones. Now actually, I'm not that crazy that I will be unsoldering each and every capacitor. I'm going to have a good look at each and every one of them, and the ones I deem very unsafe, I'm going to unsolder and change for new ones. Yeah, I'm going to replace the ones I will deem unsafe. Yeah, I think this is a capacitor 2, for example. So any capacitor which you see here is going to be changed. If there are capacitors inside IF cans, like this one, then, well, honestly, no, I don't think I will change the capacitors inside this IF can. Only if I start to align, if an alignment is necessary at all, and I notice that there is trouble aligning it, specifically tied up to this IF cam, so then I might. But you know, it's very crowded in here, so I'm really not, absolutely not relishing the idea of changing any parts inside this IF cam. One thing I can tell you, it's going to take a long time to do the whole Safari. I unmounted the part of the chassis which was soldered to the PCB, and in effect, you know, it's like a small fork, as you can see from profile. There's a small fork built into the metal of the chassis, and in that fork there are these little pins that fit right in. So there's one here, you see here. Let me see if there's less glare, like this. Okay, so you see this pin here, and then you see a pin here. Yeah, there's still some solder around it, but I'll take the solder away. Anyway, these pins fall into the little forks you see here, and these forks here, the top of the forks, fit right through those oval slots you see here. You see one here, and you see another one there. Yeah. So all you need to do really to unmount this is to unsolder these two forks, as it were, or rather the pins that are inside these forks, and lift them carefully up, and that's it. You don't need to heat them up for very long. Contrary to my expectations, apparently this metal of the chassis doesn't seem to evacuate heat all that fast, so you get plenty of time to unsolder these little pins. So now that's taken care of, on with the rest. Okay, I'm done with marking out all the spots of the capacitors. I counted them too, and believe it or not, on this one PCB there are 45 capacitors. 45. Now it's incredible they can cram that many capacitors on a PCB like this, but they did it. And let me show you. All the blue spots you see are all the capacitors I located on the other side. So each blue spot is one pin of one capacitor. So what I'll be doing the next few days is unsoldering each and every of those capacitors, and as soon as I unsolder them, I will replace them with a brand new capacitor. So you can imagine, to unsolder 45 capacitors without damaging the PCB, that will take quite a bit of time. So, like I told you guys, you better get ready for quite a few episodes of the Safari.